This is an example of calculating the vector curl. So I've got three examples labeled ABC with vector fields ABC correspondingly. And then we're going to calculate the curl, and then we're going to evaluate the curl at the specified point. Okay, so part A here, I've got something in the x direction, in the y direction, and in the z direction. So this is Cartesian coordinates system. So I'm going to just remind you that we've got the curl is this del cross A, like this. And in Cartesian coordinates, what that means is we're going to calculate the determinant of this guy. So we put our ax, ay, az, our coordinate system up there, our unit vectors, that is. Then we've got the partials on the next row. Then we put our components of our vector field. So we put the yz, this is the x component. Then we put the y component for xy. Then we put the z component, just the y there. So this is the determinant that we have to calculate, okay, in Cartesian coordinates. So the way we do this, again, we've looked at this already. The cross product. We start here with ax, and we kind of just wipe these guys out, and then we say, well, what do we have left? These four things. So I do the top left to bottom right diagonal. So the ddy operator operates on y, so the derivative of y is 1. And then the ddz, we subtract the ddz operator operating on 4xy. There are no z's there, so that's constant, so the derivative is 0. And then so this was the ax term, right? That's the term that I circled. Now moving on, then we subtract and we wipe this guy out, right? So we subtract, then we do the ddx operator operating on y. Well, there's no x's there, so the derivative is 0, minus the ddz operator operating on yz. Well, for as far as z is concerned, y is a constant, so the derivative of that is just y, and so this is ay. And then finally, we operate, or we consider this guy, and we wipe out these guys. And then what we have left is the ddx operator operating on 4xy. So the derivative of 4xy with respect to x is 4y, and then minus the ddy operator operating on yz, which is z, and this was in the z direction. Okay, so we've got ax plus yay plus 4y minus z in the z direction, and that is the curl. Okay, so now we want to evaluate the curl at this point 1, negative 2, 3. So I plug in 1 for x. Well, there are no x's there, so this thing is independent of x. And then I plug in negative 2 for y, so this gives me minus 2ay there. Not, let's see, minus 2ay. And then I've got a minus 8 here, and then a minus 3 for z, so this makes minus 11 az. So that is the vector, that is the curl of this vector field at the point 1, negative 2, 3. Great. So now we're going to move on now to B. Feel free to pause the video if you like. So in B, I see that we've got rhos and we've got z's and we've got phis hanging around. So that implies that we are in the cylindrical coordinate system. So let's recall now that there is something a little bit different in the way we calculate this this curl, okay, this cross product in the cylindrical coordinate system. So the first thing is we multiply 1 over rho by this determinant. And the determinant, we put our unit vectors up here, but for the phi component, there's this rho a phi. And we've talked about why that is when we talked about the transformation between two coordinate systems. And I don't want to cover that again here. All you need to know is that there is a difference. There are these differences in the way we calculate this cross product compared to the Cartesian coordinates. So you don't need to memorize these differences, but you do need to know that they exist, and you should have them in your notes readily available, or know where they are in the textbook. Okay, then in the next row, then this is what you would expect, right? Just the partials, and then in the following row we put our vector field. So here is the phi component. So I'll put rho z sine phi there. Now in the next component, or the next spot here, I put rho times the phi component. So here's the phi component, and so rho times this would pick up a squared there. So I've got 3 rho squared z squared cosine of phi. So that's, again, rho times the phi component, and then I've got the z component. Well, there is no z component, so that's 0. So again, let me remind you of the differences between this and what we did in part A. There's this 1 over rho that we need to be aware of. Then up here, we've got rho times our unit vector in the phi direction, and then here we take rho times the phi component. Okay, so I calculate this determinant. So I've got rho, 1 over rho times everything. So again, I do this in the same way, so I'm just not going to circle things like I did up here in different colors. So I've got the dd phi operator operating on 0, so that's 0, minus the ddz operator operating on this thing, so that's a 2. The 2 comes down in front, makes 6. 6 rho squared z cosine phi, like that, and that was in the rho direction. Okay, and then the next thing is we subtract, then rho times 1 over rho is just 1, so we subtract the dd rho operator operating on 0 minus ddz operating on this thing, so this becomes rho sine phi, and that is in the phi direction, like that. And then finally we add to that, I guess since I factored out the 1 over rho, I do need to keep this rho for now. So remember that rho is coming from this guy here. Okay, so now in the AZ direction, then I've got dd rho operating on this thing, so the 2 comes down in front, makes 6 rho z squared cosine phi, right? And then I have minus the dd phi operator operating on this thing, so I pick up this cosine. So this is rho z cosine phi. Okay, so now I carry through this 1 over phi, so this makes negative 6, or excuse me, 1 over rho. I carry that through, so that this makes negative 6 rho z cosine phi in the rho direction. Then this wipes out this rho over here, so this makes plus, but I have a rho here, plus rho sine phi in the phi direction. Then I've got plus 6 z squared cosine phi. The rho is gone because of this 1 over rho, minus z cosine phi. So we could have factored out a z cosine phi there if we wanted to, and this was in the z direction. I forgot the az there. Okay, so this is the curl of a vector field B. So now let's evaluate it at our point 5 pi over 2 1. So rho is 5. So we've got negative 6 times 5 times 1, but look at the cosine. The cosine of pi over 2, phi is pi over 2, cosine of pi over 2 is 0, so that wipes this term out. So then moving on to the phi term, we've got rho, which is 5, times the sine of phi. Sine of pi over 2 is 1, so this is 5 in the phi direction. And then here we've got cosine of pi over 2, so that's going to be 0, so that wipes out the z direction. And so at this point, 5 pi over 2, 1, we just have 5 in the phi direction, so that's nice. All right, so I'm going to erase what we did. I'm going to give ourselves some space. Again, feel free to pause the video if that part B went a little too fast. So now we're going to look at C. And so I look at vector field C and I see that we've got r's and we've got thetas and we've got phis. And so this is spherical coordinates. And so again, there are some differences here in the way we calculate the curl. And the first difference is that we're going to have 1 over r squared sine theta times the determinant. So again, this is not something that you memorize. This is something that you write down and have readily available in your notes or know where it is in the textbook. And then up here for our unit vectors, we're going to have AR, and then we're going to have R A theta, right, in the theta direction. And then over here, we're going to have R sine theta A phi in the phi direction. Okay, so we need to be concerned with those guys there. And then in the next row is what you would expect. We have our partials, right? dt phi. Okay, then in the next row, the final row, I put the r component here. So this is 2r cosine theta cosine phi. I'll just write it like that, but that's multiplying. And then here I've got the theta component. So I look at my vector field C and I don't have a theta component, so that's going to be 0. And then I put my phi component over here, but not only do I have my phi component, if you recall from the transformation, I need r times the phi component. R times the phi component goes here. So this is r to the 1/2 power, so r times that would be r to the 3/2 power. Okay, and what else do I have to multiply? I need a sine theta, sine theta there. So this is r sine theta times whatever comes up here. You can remember that because r sine theta is also right here. All right, so again, we just carry out this determinant. Okay, so we've got 1 over r squared sine theta times everything. So I start with circling, the AR, and then we do this d theta operating on this thing. So that makes r to the 3/2 cosine theta minus d phi operating on 0. So that's just 0, right? So that was in the r direction. Then minus r times ddr operating on this term here, r to the 3/2. So the 3/2 comes down in front, subtract 1, so that makes r to the 1/2 sine theta, okay, minus dd phi operating on 2r cosine theta cosine phi. So the derivative of cosine phi is plus sine phi, so this makes plus 2r cosine theta sine phi, and that was in we need a phi. Then I'm going to add to that r sine theta times ddr operating on 0 is 0 minus dd theta operating on 2r cosine theta cosine phi. So again, that picks up a positive, or that puts up a negative sign that makes that a positive 2r sine theta cosine phi, and this is in the phi direction. Okay, so I'm just going to continue that over here. All right, so I've got this 1 over r squared sine theta to distribute in. So I've got, when I distribute that into the r direction, I've got r to the 3/2 divided by r squared. So r squared is like r to the 4/2, right? So I've got 1 over root r, like that. And then I've got cosine theta over sine theta. Cosine theta over sine theta is actually cotangent of theta. Okay, so that's my curl in the r direction. Now here I've got 3/2, okay, so minus 3/2. I'll keep the minus out there. When I distribute the r in, I've got r to the r times r to the 1/2, which makes r to the 3/2, but then divided by r squared, which again makes root r. So I've got 3/2 over root r, and then a sine theta and a sine theta, well, that cancels. Okay, then I've got plus, and again, if I distribute this r in, I've got r squared, right? But then divided by r squared, so that wipes out. And then I've got cosine theta over sine theta, so that makes a cotangent theta again. So I've got 2 cotangent of theta, and then I've got that sine phi hanging around there. And again, this was in the theta direction, like that. And then finally, the phi term, okay, when I distribute this in, so I've got first of all this r to distribute into, well, to 0, so that's good, right? That's gone. Then I've got this r to distribute in, makes r squared, but that cancels with this r squared. And then distribute the sine theta in, so that makes sine squared theta, and I've got a 1 canceling with that guy there. So this makes plus 2 sine theta, and then I've got a cosine phi there. Cosine phi, and that is in the phi direction, like that. So this is the curl of vector field C. So then I evaluate it at r radius of 1, right, and a theta of pi over 6, and a phi of pi over 3. So when I do that, when I put everything in there, I get the square root of 3 in the r direction minus 9/2 in the theta direction plus 1/2 in the phi direction. And that's all there is to it. That's the answer.